So in this video, we'll start from the DBFS, Databricks file systems, which is the cloud-based file system in the Databricks itself. So if you go to the upload file here, you can see the option upload files to DBFS. We are going to upload this customer.csv file to the DBFS. So here I'm clicking on the upload files to DBFS, and here I'll drop this file customer.csv. And you can see the path it's stored in the file store tables customer.csv file store tables directory. And if you want to browse this, you have to enable the browse DBFS options from the settings. So here from the advanced, search for the DBFS, and here the DBFS file browser, these options you have to enable. Now if you go to the catalog, you will see the options, the browse DBFS. Let me refresh the Databricks workspace. So here we have these options, the browse DBFS. If I click on it, I will get the file store, and inside file store we have the tables and the customer.csv file. From here you can copy the path of the customer.csv and you can load it to the Databricks from notebook. So first let me list whatever files or whatever directory we have in the DBFS. So we can utilize the %fs, which is the magic command used within notebooks to interact with the Databricks file system. So it will allows you to perform the file system operation directly from the notebook sets like the ls I am using. So you can list directories, copying, moving, removing files, and displaying the contents using this %fs magic command. And you can see inside the file store and tables we have this file. Now I'll copy the path of the customer.csv and I'll try to load it into a notebook. So I'll create a new notebook. And I will name it the customer analysis, and I will load the customer data from the customer.csv to our data frame. So basically a data frame in Apache Spark is a distributed collection of data organized into rows and columns, similar to tables in a relational database like the Postgres or the MySQL. It serves as a core abstraction for working with structured and the semi-structured data. So here I stored into a data frame and I am displaying the data frame, and you can see the customer data from the customer.csv. Now I'll do some operations on the customer data. So when I load this customer.csv to the data frame, you can see we have the inverse schema true. So based on the values on the CSV, it's actually uh, assign the schema. But if you want to define the schema, you can do with the struct type and the struct field, where you can explicitly define the data type for each of the column in the CSV. Now you can see whatever I defined, it's actually showing here. Now I will apply some filtration on the data frame, and I will store into the another data frame on display. So here I am filtering the data frame based on the country India. So it will show all the data which have the country India. Similarly, you can also apply the SQL like query, like you can apply where condition, and you can apply the multiple condition like the country India and the customer which have age greater than 30. So it will give you the results where the country is India and the age greater than 30. It's just like the SQL query. Next, if I want to add any column, extra column to the data frame, we can do that. So here I am adding one column like the new column, and the value will be the value in the age column plus 10, the new column. And here we can drop this column also, the rename it the column. So here I am renaming the age column to the new age. So here you can see the three data frame first, where I added a new column integer. Next I drop the column, and next I rename the column to age to the new age. If you see the DF4, you will not see the new column because I dropped it. And in the DF5, you will get the new age instead of the age column. It's renamed. Now I want to add one more column like the seniority. So I will put a column which will hold the value senior or junior based on the age. So here I am adding this seniority column and applying when. If the age is greater than 50, it will be shown as senior, and otherwise it will show junior in the seniority column. So let's see. Here in the DF6 you can see we have the seniority column and we have the value according to this condition. Now I can select the column which I want, like the select column from the SQL table, and we can store it into the another data frame. Like I am selecting the age, gender, city, customer type, and we can also use, like we can store like we can select like the column age into 10,000. I want to select this, and I will put a name here like the alias salary. So whatever the age, I am putting multiple of 10,000, and I am selecting a new column salary. So I need to define the call from the SQL functions. So here you can see that we have the age, gender, customer type, and the salary, which is 10k times multiplication of the value of the age. Now I'll go to the catalog, browse DBFS, and here I actually stored one state example. So I'll fetch it, and I'll show you how you can represents the nested JSON into a data frame. So first I will load this nested JSON file. So if I display this data frame, so it will be DBFS column file store. Your path, and you can see we have a address field where we have the object like city, state. And now I will select those city, state, street, whatever we have in a separate column like this, the df1 dot select address dot star, and I will display the df2 data frame, and you can see we have all the fields in our table structure. We don't have any nesting thing. So yeah, that's why we can handle the nesting part in the flat uh, table. Now I'll show you the join between the two data frames. So that's why I am creating data frame 1 by filtering the customer type premium and the data frame 2 with the customer type regular. Next, the DF3 will contain the join of the data frame 1. Sorry, here I am doing the union, not the join. So here I am union the premium customer type and the regular customer type. So you will get all the premium and the regular customer type here. We can also print the distinct customer type here by df3.select customer type dot distinct, and we can see mm, how many customer type we have in the data frame 3, and you can see we have the premium and the regular. You can also see the count, how many records we have in the data frame where we loaded the customer.csv, and df.na.drop will actually drop all the null columns from the data frame, and we can then check how many was there with the null columns, how many rows we have in the data frame where we have the null values. Here in the data frame 2, I am also storing the rows where email is not null. So I'm filter by the column email. Sorry, I need to display the count of the rows where email is null. So df2 will give me those rows where email is null. Basically here I am checking. First I am removing null values from the data frame df.na.drop, and next I am filtering those data frame where email is null. The df2 should be empty result because we remove null. Here you can see the count here. First there is the 106, and there is the 5 rows where we have the null, and next we have the count 101. Now what I'll do, I'll replace the null values of email with unknown. So the function is the fill na or na.fill, and here you have to mention which field you need to replace with the unknown. Here it will basically replace with all na values with unknown. And here I am mentioning which fields I need to replace. If the email is null, then it will just fill with unknown, and here is the result. Next I will create another block, and here I will show you the order by age in the descending order, and along with you the gender ascending. And here we can provide the age, gender in the array, and the ascending descending we can mention the true false. So here you can see the age is in the descending order and gender is in ascending order. If we reverse this thing, like the age in ascending and the gender is descending, you will see the reverse results. So -1 actually appearing first. We can also mention that the -1 will be appeared in first, or I want to show them in the last. So here we have the option descending null first, or we have the option like the descending null last. Here you can see the results. Next I'll show you the group by query, group by gender and the count. Sorry, group by gender and the customer type. By group by we can get the sum, average, total count, etc. Whatever aggregation we want to do. Here you can see the count, group by gender and the customer, where you can see how many there is the female with the premium customer type, other with VIP, and the female with regular. Now I'll evaluate the maximum age by gender. So here you can see female maximum age is 79, and other gender we have the 78. Now I want to get the results of sum, max, mean, average. age by gender. So I will write the query for it. It's showing only the average. We have to separate this thing so that we can get all the things like the sum, max, mean, average. Here the average is not able to find, so I have to define the average functions from the PySpark SQL functions. And here you can see we have the sum, max, mean, and the average of the age by gender. So next query I will write to make country in the uppercase. So we can do like with column country and the upper. We can use the value of the country. And you can see the results. All the country name actually becomes in uppercase. Next, I'll write the query for the day of week of the registration date. So what is the day of the week, the registration date, and also the week of year. For this, I will use the with column function. And here we have the day of week function and the week of year function. So you can see the day of week and the week of year of the registration date. And you can also do the formatting update in which format you want to represents the date. You can mention it. So here I want to format it MMMDDYY. Here I am getting an error that the format date is not able to find. So let's debug this. Here I am taking help of AI. The AI chat we have inbuilt in the Databricks. And if I show you the result, the registration date, you can see the formatting. Now, whatever transformation we make, if I want to store into the another CSV file in the DBFS, we can do this by df2.write.csv, and it will store this data frame into another CSV into DBFS. So now now I created a new notebook, Spark SQL, where we'll see the different SQL things, like the view, manage tables, external tables, all the things. So first I will read the CSV file from the DBFS. So in our file store, we have this customer.csv. So I'll copy the path of this customer.csv. Here I am using the spark.read. This is the data frame reader object, and I will mention the header true and the infer schema too. This option tells Spark that the first line of the CSV file contains the column names, the header true. Spark treats the first line as data without this. And next, the infer schema 2. This option instructs Sparks to automatically detect the data types of each column by reading the data. And I am storing into the data frame. The result of this operation is a Spark data frame. This means you now have the distributed table-like structure representing the CSV data, which you can process using the Spark APIs or the SQL query, whatever you want. So now I am creating a temporary view out of this data frame. So the command is a create or replace temp view customer. Now I can perform the SQL operation on the customer temporary view. So basically temporary view is a season scope, that is in-memory table-like structure created from the data frame that behaves similarly to the view in a traditional database. Its key features is include being temporary. So whenever the current session will be over, it will be removed. It is transient, not saved to this, and accessible via the SQL query. You can see I can do the select star from customer. It's useful for ad hoc analysis and act as a bridge between PySpark coding and SQL. And here you can see the results of the select star from customer. Next, I want to list all the views present in our Databricks. So here is the command display spark.sql show views. It will list all the views. So here we have only one views which we created recently, the customer. Next, if I want to drop the temporary views, so I can drop it by writing the command that drop view customer. Mhm. So you can see we don't have any views after dropping the customer temp views. Next, I will create the global temporary views. It's similar to the regular temporary views, but differ in that they are accessible across all season within the same Spark application, allowing multiple notebooks or user to share the view. These views are stored in the special database called the global temp and exist only for the duration of the Spark application. Like regular temporary views, they are not stored. They are stored in temporary memory but not persisted. Like regular temporary views, they are stored in memory and not persisted to disk. When the cluster is shut down or restored, global temporary views are dropped. Here we can also do the same. All the SQL query will be supported on the global temp view. Next, we'll show the manage tables. So I'll create the manage tables. In SpicePart, the manage table is the where Databricks manages both the data and the metadata. Metadata means the table names, columns, and the data type, as well the actual data will be stored. When you create a manage table, the data is stored in a default or specified database directory within the database workspace. Dropping a manage tables detects both, delete both its data and the metadata, similar to the traditional SQL tables. And managed tables are registered in the Databricks metastore, which tracks their metadata and allow access from multiple places. The key advantage of the managed tables are the Databricks handles the life cycle of both the data and the metadata, and they are easy to use. They behave like the regular database tables. So here we have some data is in the ingestion timestamp. That's why I am dropping this ingestion timestamp column from the data frame, and I will create a managed tables. So here you can see we have this managed tables, the customer tables. And if I describe the managed tables, you can see all the informations of the managed tables. Here we have this metadata, like whatever column and its data type we have, its catalog, its database. Other than managed tables, we have the external tables in Databricks, where the Databricks manage only the metadata, the table name, column information, while the actual data resides in the external storage locations like the ADLS, AWS, DBFS, or the global cloud storage. Unlike managed tables, dropping an external table does not delete the underlying data, so it ensures the data safety. External table supports various file formats like Parquet, Delta, CSV, etc. Next, we'll see the Delta Lake, how we can do the operations in the Delta Lake. Basically, Delta Lake is an open source storage layer that enhances data lakes by adding the ACID transactions, schema enforcement and evaluation, and unified support for both batch and streaming data processing. It enables reliable concurrent read-write operations, handles schema changes over time, and provide time travels for easily reverting or auditing data changes. Delta Lake support DML operations like the update, insert, deletes, which traditional Spark tables don't have. It highly scalable and optimized for the large dataset with features like the file compression and the JAID ordering. It's basically creating a modern database and capable of handling complex data analytics. So here I am creating a database here, the retail DB, and if I list all the databases, so we will see we'll have the default database and the retail DB. We have to put the display so that we can get it printed. So here we have the default database, the information schema I created, and the retail DB. Next we'll create a delta table. I will name it the customer delta. So here my format will be the delta. And I will save as tables and I will put the table name. So we have some issue with the value of the ingestion timestamp. So let's remove the ingestion timestamp column from the data frame and use the data frame to create the delta table. Now the delta table created successfully. Now if I describe this delta table, you can get its metadata, and provider you can see its delta. Now I'll display the total rows in the customer delta. So we can just select count start from the delta table, and we have 6 rows. Next, I want to insert a new row to this customer delta table. It will be similar to the SQL query, inserting to the tables and the values we have to provide. Let's check what columns we have in the delta table. So you can see there was the 6 rows, and now we have 7 rows. So we inserted 1 rows to the delta table, and you can see the customer ID this one, and with the name John. Next we can do the update table. I want to change the customer type. And you can see it's updated. The customer type we updated to regular. Now in the delta lake uh, we have the options to we can make the time travel. So I am displaying the history. Whatever operation we make, it's actually create a version of the table. So you can see first we create or replay create tables, then we write data, we insert a row into table, then we make update to the tables, So basically it's create a specific version 0, 1, 2, 3. You can switch to a different version. You can restore any version. It helps in reverting or auditing data changes. So if I want to see any specific version, we can do that. So it's before inserting a row to the delta table. So it's the base version we created. And here you will see we have the 106 rows. Now if I want to display the version 3 where we have this uh, insert new rows along with the update in place. So you will get we have the 107 rows, and you can see the rows, the newly inserted rows. We can also display data based on the timestamp. So if we have the timestamp, we can load based on this timestamp, like the timestamp as of on this timestamp, whatever data we had. And next I will show you the restore. If I want to restore any version, I can do that as well. So the command is the restore table retail db.customer to version as of 0. So I want to revert to the initial version. Now we can see the in version 0 we'll have the in the version 0 we had 106 rows and we restored this version. Next I created another notebook where we'll see the different join operations. For this, I will use the same customer.csv file. I will load it into the data frame. I'll create two different data frame by filtering the customer type so that I can perform the join between them. So here you can join, you can mention on which column you want to join, and the join operation, how will it will be inner join or outer join, left or right join. Next, we'll see the broadcast join. It's a join technique where the smaller data frames is broadcasted to all worker nodes to optimize performance by reducing the data shuffling. Instead of moving both a large data frame across the cluster, only the small data frames data is sent to each node, which improves speed, especially when joining a small dimension table with a large fact table. Broadcast join works best when the smaller data frame can fit into the executor node memory. So here you can mention the broadcast and you can do the join. Here if I explain the output, here you can see all the broadcast joining uh, plan it applies. Next, we'll see the bucketing. Bucketing in PySpark is an advanced data optimization technique that divides data into a fixed number of buckets based on a chosen key column. The key column is processed through a hashing function to evenly distribute rows across the buckets, with each bucket stored as a separate files. Bucketing improves performance by reducing the data shuffle, especially during the join and aggregation. When both tables are bucketed on the same key and have their same number of buckets. Next, we'll see a project, a small project in the Databricks, where the project will focus on retail sale analysis to optimize the store performance. For this, uh, I stored the sales data and store data into DBFS. So it will include the cleaning and the preparing sales and store data, adding new columns for advanced insights and analyzing store performance and product trends. The dataset will contains the sales ID, store ID, product ID, sales data, quantity and total amount, and store data with the store ID, region, open date, all the things. Here we'll transform the data, which will involve the joining the dataset, creating new columns such as sales per square foot and sales year, and aggregating sales and quantity by store. And region, the analysis aims to identify the top 5 stores by total sale and the top 5 products by quantity. So here I am creating a notebook retail project data cleaning. Here I'll read those CSP. One will be the sales data frame and another would be the stored data frame. Here I am cleaning the data, filtering sales step, remove row where the sale ID, store ID, those are null, and the sales state also. Now, if you see, we have the -1 quantity, so we have to make it correct. So quantity can't be negative value. And we also have the total amount, it's negative. So here I will apply the filter and remove row with quantity and the total amount is less than 0. Now our sales data is cleaned. And one more thing we have, like we have the null quantity, so we'll replace the null quantity with and total amount with 0. Now we need to clean the stores data frame, the source data we have. Similarly, we make the sales TF. Here you can see we have the store size null. So we already filter out the store ID null and the open date null. We have the store size null. So for the store size, we will replace with the average store size. So first we'll calculate the average store size. Now our stores data frame also cleaned up, and now I'll join the sales TML stores data frame by store ID. So here my join type will be the inner join. Now this join data frame, we have the sales data along with the stored data. Next, I will create a column like the sales per square feet. From this join div, I will create a temporary view which will contain the store ID, the region, total sales, and the sales per the total quantity. So total sale will be the sum of the total amount and the total quantity of the sum of quantity. Now here I am selecting the store ID, store region, the total sales and the quantity, and I will store it into a data frame like the store sales SQL or the SQL queries. So I will display the stored sales SQL, and from this I want to get the top 5 product based on the total quantity. Here we have this top five product with the product ID and the corresponding total quantity. And next, I want to get the top five stored based on the sale. So here we have the result. So that's it for today's video. Bye.